So welcome back. We're going to continue graphing linear equations, and we want to use these x and y intercepts. Again, to find the x-intercept, our key is to set y equals 0 and solve for x. And again, to find that y-intercept, we're going to set that x equals 0 and solve for y. So I do have an equation this time, and we do like it in this form when we're trying to find the x and y-intercept. It just makes it a lot more natural. So if I'm going to find the x-intercept, I'm setting y equals 0. So this term disappears, and what you're going to have then is, since this disappears, you have x equals 12. So in my table, we end up with 12, 0. Because remember, when you put 0 for y, 4 times 0 is 0, so that term just falls out of the problem. So all you have is x equals 12. So the x-intercept will be 12. The y-intercept, we have to set x equals 0, so this term falls out. And what you have is negative 4y is equal to 12. And then if I divide each side by negative 4, I get y equals then negative 3. So my y-intercept is going to be 0, negative 3. So I'm going to graph those 2 points, 0, negative 3. And we have 12, 0. So I'd actually make a little longer graph here. So 12, 0 would be out there. And again, to graph, we still got to draw a line through those 2 points, and that will create the graph of our equation. So if I can line those up, that goes a long way out there. Let's see if I can get that to work. Okay. So that would be the graph of this equation. Also take note, as we move from left to right, the graph kind of has more of a decreasing direction. So sometimes the graph will go in a decreasing direction. This graph actually goes in more of a increasing direction. Also notice that it wasn't as steep as the one we did before. This doesn't have as much steepness to it. It's not increasing by a very quick rate. And those are some observations we want to continue making. It's this concept of direction and steepness. So let's see what next comes for us. So stay tuned.